Hi everyone, I'm going to show you a brief video here of how to use this Plotly software so that you can plot some graphs. So what I'm going to do here is I'm going to put some data here. I'm going to copy it right into here. And essentially what I'm doing here is this is data that's looking at the acceleration of two cars, okay? So this column A here is just the number of seconds. So after each second goes by, and then column B is one car. And so after each second goes by, it's telling me its speed in miles per hour. And then column C is a second car. Again, telling me what speed it's moving at in miles per hour. And so if I wanted to compare the accelerations, I could graph these two, see if, how they compare. And I could also plot them, make a little scatter plot here and see if they follow some sort of pattern, like a linear pattern or an exponential pattern. That will tell us some other information about the car's acceleration. So what I'll do here is up top where it says plus trace, I'm going to add a trace, and its default is scatter. And then I could choose what I want the x-axis and the y-axis to be. So I'm going to plot velocity versus time, because that graph, the slope of that graph will give me acceleration. So on the x-axis, I'll choose A, the times, 1, 2, 3, 4, 5, each of those seconds. And then we'll first look at column B, that car. Okay, and now you can see I got my 5 points here. And it looks pretty linear to me, but we could test that out. And so on the left side here, you'll see this Analyze tab. And underneath that, you'll click on Curve Fitting. And then there'll be a plus fit here, so I can add a fit. And so it's going to ask me to select which trace. Well, right now we just have that one trace there. And it automatically gives me a family function of linear. It's set to automatically. And so if I click on Run down here, you'll see it'll apply a linear fit to it. And yes, it does look pretty linear. So you could choose other ones, exponential, quadratic, but that pretty much looks like a linear fit. So we already know here now that it's pretty much this car is moving at a constant acceleration. And we can see here, it even tells us the slope of the line. So remember, for a linear function, y equals mx plus b. And it's telling us here our m, our slope, okay? And b, the approximate y-intercept based on this linear fit that the software has done for us. So now, obviously, if the car started from rest, this b, this y-intercept should be 0. I'm not sure what I did there. Let's try running it again. There we go. And so this is where we could see that there's a little bit of not perfection here, right? So we see the dots are not a perfect linear fit. So we're not going to get exactly the right y-intercept, but we could see here that the acceleration is about 14.5 miles per hour each second. Okay, and now we can go back, click up the traces, and we can add another trace. And again, our x-axis will be time, but now we'll look at the car in C. And now we see some green dots here. And again, we could try to go to curve fitting. We'll click run to see that linear fit. Or actually, we need to add a fit, because right now it's still set to the original trace that we did. So we'll have to select the new trace, trace 2. And then we could click run. And now we see, yeah, it is pretty linear again there. And just by looking at this, we can tell that these are just based on looking at the graph, we could tell which one has the greater acceleration, right? The purple one is definitely a lot steeper. And if we look at the numbers here, the M's, we compare the M's, so it's about 10 miles per hour per second for the green car represented by the green line. And then we said 14.5 for the car represented by the purple line. So yes, indeed, it was a greater acceleration. And then if you want to use some graphs here to present in your poster, you can click on to enter the plot title here, and we could maybe I'll call this car acceleration comparison. And then on my y-axis, I can choose the title. So I could say it's velocity. And then you always want to put your units in there, miles per hour. Then our y-axis was time and seconds. And now we have a pretty neat graph, a decent graph that we can actually share with others as we present and put on a poster or in any kind of paper or anything you're going to write. So it's pretty decent here, and you could take a nice screenshot of that. That will give you a really decent graph that you can share with others.